In Illinois, I first learned to speak German at home and then English from all the neighbors and friends. I also had to play violin from a young age. I didn't like it very much, but eventually I picked up viola because there's a shortage of violists, so they treated me nicer. So I learned how a violinist, even me, I'm not that good a violinist, but still I endlessly would practice some short passage just to get the vibrato exactly right, to get the bowing exactly right, to get the spiccato alternating with pizzicato or whatever the weird thing is, getting right, or the artificial harmonics. Being an incompetent player, those were always awful. Well, at least you could tell when you're not doing it right. But no, I could tell I couldn't do it. It was pretty tough. But I really grew up with this thing where really listening closely, not just for intonation, but for all sorts of aspects of expression. And anyway, from this violin experience, I learned lots of things. One of the things is that expressive playing requires skill and dedication. I go to NAMM and I go to Musikmesse and these things, and it's amazing. You know, there's always, oh, be so expressive, and it won't take any effort, which is, you know, an oxymoron. And anyway, it's a very bizarre thing. I'm firmly convinced that's not true. I also learned other things from playing in orchestra and being around a lot of acoustic instruments. If you're a flute player and you want to pick up trumpet, say you're a world-class flute player, and in 2 weeks you want to play a trumpet concerto. You've never played trumpet before, but you want to play it with some, you know, world-class orchestra as a solo. Well, people laugh at you. I mean, it's just a joke, right? In fact, if you practice for years and years, if you practice for the rest of your life, you may eventually get to be a good trumpeter, but you'll have ruined your lips. You won't be able to play flute anymore. I mean, there's a huge amount of buy-in there. And the same thing goes, you know, for all these acoustic instruments. There's a huge amount of buy-in. So when I learned about synthesizers, boy, that world is different, you know. You press the flute button, and then you press the trumpet button, and it's all the same. No new skills to learn. And you actually, if you have a good sample library, you actually sound pretty good. So that's a really different thing. The buy-in is extremely low. And people expect synthesizer technology to make things easy. You know, when you buy a violin, nobody expects a violin to make it easy. I mean, you buy a chin rest that makes it easier. You do this and that. You know, you do adjustments, or you use strings you like, or the horsehair on your bow that you like, or a different rosin or something for a particular piece to make that one easier to play. But, you know, nobody expects the violin to be easy. And in fact, the expensive violin isn't the one that's easier to play. So it doesn't, you know, it's a very different thing. So yeah, so the synthesizers, you know, people don't want to practice. People will have played piano since they were 3 years old, and practiced for many, many hours a day. They sit down with a synthesizer and it's supposed to work right away, especially if it's expensive. So that's kind of a weird thing. In fact, I've talked to great contra pianists. Is Rob here yet? He's still in bed.
Rob is just coming in.
Oh, okay. Well, you know, a pianist, if at all possible, will play on that piano tuned by the person who's going to tune it, or has tuned it for the concert, in that environment, because the best pianos aren't like typewriters. If you play evenly, you don't hear even sound. They're uneven. You learn how each key responds. And, you know, as these pianists tell me, typewriter pianos are the ones where you play even scale, you know, even loudness, then it all comes out, or even pressures, even velocities, and it all comes out even. So there's all sorts of skills, even in those instruments, that don't transfer at all to synthesizers. Being an engineer, you know, an engineer's job is generally to make things easy. So it's understandable that this has happened, right? Synthesizers, the whole idea was to make it easy. It's also understandable that people don't like to practice. I mean, I remember as a kid, I was so angry at my little brother because I hated practicing every day. We had to get up at 6 in the morning and practice, and it was awful. And my little brother absolutely was a cheat because he liked it. And he's actually a viola professor now, but he liked it. And it just burned me up. I just never got over that. But I can understand that people don't like to practice. On the other hand, you know, musicians are proud of their skills, and it's just so bizarre to me to see people get a new instrument, new electronic instrument, and, you know, expect the instant gratification, even if they're great players. They still have that same mindset. So it's a very odd thing. Another thing I learned is that it's enjoyable for me to listen for hours to any instrument. Pick any instrument in the orchestra. They're great to listen to. I could listen, you know, I'm not an oboe player. I can listen to oboe solo or oboe with piano or whatever, pick anything. Pick any small combination. I can listen to the oboe alone, though, for hours and still want to hear more. And there is not a synth patch in the world that I can sit and listen to a single patch for hours and want to hear more. That's just not there. That's a real revelation to me. And then also this other revelation, which I think is what draws people in, is that synthesizers are great at making a huge variety of sounds. I just talked about all the instruments of the orchestra. Well, synthesizers go way beyond that, right? You can make the sounds of the helicopters. You can make sounds of, I don't know what, cowbell. Well, that's an orchestra instrument. But you can make, all sorts of sounds that even all the instruments of the orchestra, no matter what they do, they can't make. But the synthesizers can't do small nuances. They do play small nuances all the time, but they're always canned in the synthesizer. They're prefab. So anyway, that's what got me to doing the Continuum fingerboard. Is it 9:10? Is my time right?
It is 10:10.
10:10. Well, okay. But in my okay. Well, that's pretty good. Oh, and I didn't scroll up, and nobody told me to. Look. Anyway, I'm just saying what's on. It doesn't matter.
Oh, scroll up.
Scroll up. Yeah. I'm not scrolling up breakfast. No. Okay. So what's next here? Okay. So I've been working on the Continuum, making continual improvements for decades. So in that way, I see myself as a kid. I learned in Lübeck in Germany when I was visiting there. I got to know a violin maker there, and in that way, I find myself closer to that than most electronic synthesizer makers. I've been working on the same thing forever, and there's examples of this in the synth area. For instance, the Moog Voyager, right, has been continually worked on and improved over many decades. But anyway, I've just been doing this one thing. I've been doing the Continuum for decades. So I have these timeline. These times aren't super accurate because I worked on it for over all these years. I have a family. I have 4 kids and a wife. So I had to do the pesky day job thing. Lots of things got in the way of it. But yes, I've been working on it. Having a violin background, I knew that the difference between the $100 violin and the Stradivarius, it's very small. Like people look at alternative controllers and say, "Oh yeah, you wiggle your fingers, so they're all the same." But no, I mean the difference between those things, are tiny. In fact, if you look at the Stradivarius, it looks old and beaten up and kind of crappy, and you look at the $100 violin, it's nice and shiny, fresh from China. And if you have a great violin player play that $100 violin and really try to play it well, it'll actually, to somebody who's not used to listening to violin, it'll even sound quite good. You'll jump out at somebody who's uninitiated, who's not a violin player, not familiar with violin music, that it's a crappy little instrument. So it's actually, it actually isn't. It's actually 99% of what the $100,000 violin is. So the tiny differences matter, and I spent my whole time working on the tiny differences. So I didn't worry about cost, which means I have to have a day job to earn a living. I didn't worry about cost. I really tried to make the best instrument I could, and I've always been doing that, and I'm still doing that. I also didn't worry about other things, like there's, it's a rectangle. Actually, I don't mind rectangles, but it's very utilitarian in that way. Ed and I have had these discussions because he designed the stand.
Well, assisted. I had an engineer.
All right. He always gives. Nobody does anything by themselves. But no, he made the stand, and the stand is great because I got 2 of them. You can buy them, by the way. They cost too much and they weigh too much. But this one here is actually a stage Continuum. Well, not this Continuum, but the stand has got wheels on it, just like you would have for a piano and a big stage. And you roll it in. I mean, your grand piano, it's not very portable either, and hey, that's the way it goes. If you have your multi-million-dollar concert hall and your orchestra there, and you want to perform with the Continuum, I highly suggest the stand. If you have a studio, they're wonderful too, if you don't move it very much. If you are a traveling gig person, you'd be whacked to take this thing. But in any case, it is a very nice stand. Oh, it was
a different foot design. I thought it had been misplaced there. It might slide off.
All right. So anyway, so the stand makes up for the utilitarian aspect, but yeah, so everything I talk about here is really about trying to make the most expressive instrument I can without primarily worrying about, a piano builder I met, a very nice person who works for a very high-end piano company that I probably, probably better not to mention. I don't know if this sounds bad or something, but the vast majority of the pianos they sell, they're very expensive. They're start at $80,000 and go up from there. They're almost all of he calls architectural pianos, which means if you got the $10 billion but you got to have a piano in it because that's what $10 million houses have, and it's got to be a cool brand. But even those, he said, well, every once in a while, like the kid of this rich person actually sits down and plays. So even that's good. So if we can make architectural continuums, hey, I'm all for it. Put in your $10 million house. All right, so as a grad student, I wrote up the continuum descriptions with magnets and Hall effect sensors very early on. This is on Plato in 1982, and this is a picture. Now this picture was actually drawn by a draftsman off of hand sketches I had. I couldn't find hand sketches, they're cooler. But this is from a very long time ago. You'll notice a few things. These things look like, they're square rods because I thought a flat surface at the top would be better. In this case here, the magnets come down. In this case here, the magnets are on the out. I was going to try different things. There's a mylar sheet on top. Mylar's great if you're really sweaty, and if you're not really sweaty, it's actually kind of hard to move your finger on. But I didn't know any better. There's magnets here and Hall effect sensors here of the kind that they used to have back then. The springs, of course, are more work intensive, so I also went for doing just having rubber underneath the rods. It turns out after after several decades, I figured out that springs and rubber together are the way to go rather than one or the other. So there you go. Okay, so that was in 1982. And already then I knew sort of what I was getting into. The advantages of continuum were supposed to be that you could finally shape the evolution of each note. There were ribbon controllers back then, but again, most keyboards, even analog keyboards, mostly, the job is to start and stop. The advantage of keyboards, which is huge and not to be ignored, is that you can play many notes quickly and accurately. And in the acoustic world, piano isn't the same as a synthesizer keyboard, but in the acoustic world it's certainly true that a piano can play way more notes, way more quickly, a whole wash of sound, where a violin, 3 note chords, maybe 4, is it. So it's a similar sort of counterpart in the acoustic world. So I was doing all sorts of music stuff there. We had some other music systems, designed several synthesizers before this, but in 1984 I had I actually designed it earlier, but then it sat for a while. By 1984, we were actually building it. So that's a high-powered audio DSP for sound computation. Now, at the time, I was convinced that additive sine wave morphing was ideal for the continuum. And at the time, I had figured out that what people were doing that wanted to do additive sine wave synthesis, make a hardware that can generate thousands of sine waves. But actually, that's the easy part. The high-level computations for how do you do the morph is the hard part, and there's lots of parameters control. So anyway, this is a block diagram. I don't want to spend too much time on this, but it looks pretty similar to what DSPs have inside them nowadays. You don't see all the buses here. It has multiple buses, or sort of Harvard architecture. It's got 3 multiplier accumulators. That's the only ALU it's got, because as long as you can multiply and you can add, and it can parallel load them and stuff. So, and then it's got a very wide instruction word that's not shown here. But anyway, it's for that time, I could buy these multiply accumulators, or nice 64-pin chips, about that big, and they were actually mostly made for the Cold War to do code cracking and that kind of stuff. But I used them for these nefarious purposes. Kurt Hebel then, because it was really quite a general-purpose processor, he needed some new memory addressing modes and stuff. But actually, later, Kurt did a lot of work in the assembler and extending the hardware too for better memory addressing modes. So it became the first Kima platform. Anybody here familiar with Wayne's World?
Yes.
Okay, so here's a short Wayne's World excerpt. I think this is it.
Well, not all of them. Oh, the back. Well, yeah. Okay.
Okay. Well,
So that's a.
I don't want to hear it. It's too embarrassing. But okay. Here.
This is in this rainbow case.
Right, and it's based on multiplier accumulators. It's got 3 TRW multiplier accumulators.
The ones are right here, huh?
Right,
Was it what, 50?
Anyway, yeah. So that was a part of that, the big wire port, and then that wasn't even A to Ds and D to As. At that time, we didn't have digital audio yet, so the A to Ds and D to As were $600 items that then had another $600 worth of analog filters after them. So you could do variable sample rate. So that suddenly went to $2 when Philips made the CDs. Okay, so I experimented with lots of things early on, lots of different techniques. One of the cooler ones is, I don't know if you can see this stuff. I was going to bring this sheet, but it just looks quite yellowed over time. It looked kind of gross, so I left it home. But yeah, so photoelastics was cool. I had a CCD camera with a polarizer in front of it, and then a light with a different polarizer on in front of it. As you press on this photoelastic surface, you get rings around your finger, which was pretty cool. But the processing power at the time could not resolve these figure eights and stuff you get when you have your fingers anywhere near each other. So it was also, you had to press pretty hard. Also, the light had to be, for the CCD cameras today, the light was so bright that the plastic started melting after a while. Yeah, very slow. But in any case, it's cool, and I'm surprised nobody's followed up on photoelastics at all. Another thing I did is I did custom-made materials because I wanted to have a real 3D array. This actually worked. I had many other things, but this actually worked. So I made this rubber. It had carbon fibers that were vertical in it. When it was cured, they were put in vertical, and it worked great. And just had it was actually quite accurate, quite good. They were close. There was a close enough grid that your finger would cover a whole area of them. So you would get basically using blob detection techniques like you would for vision. You could get very, very accurate stuff. It turns out you play it for a few minutes and carbon fibers break down and it's not so good anymore. So anyway, so it was a cool idea for the first few minutes.
Lippold, do you mind questions?
Yes.
Or do you want
yeah, sure.
You know, with the figure eight thing, did you have success if it was just circular?
Yeah,
So
single fingers. Oh, okay, so at the time we had limited computer power, and actually, to try to do things in real time. At that time, real time meant like 15, 20 milliseconds, not 300 microseconds like Continuum now. But in some reasonable number of milliseconds, the camera could actually get you an image, and with a very expensive computer, you could do circle detection. Because circle detection in graphics is a specific thing that's actually quite optimized. But as soon as you went away from circles,
the interference of the two circles joining together.
yeah, because you can do circle detection on this, but it doesn't degrade nicely as you would think. So you can't. Yeah, it's very so the processing power was enormous back then. But anyway, it would be a cute thing. Okay, so what am I doing here? So I just always came back to Hall effect sensors. Even at that time, the Hall effect sensors that I got at that time were not as good as the ones I have now, but all the same, they're just super accurate. It's really hard to find any sensor that over a small distance, like if you want to go half a centimeter or something, or even a centimeter distance, will give you 14 bits of accuracy. That's really hard to get. So
6 foot long in this direction.
Okay.
And if you rock your finger, you want to be able to detect that. Or what happens is anytime you're pressing on this Continuum, as we call it here.
Continuum.
Anytime you press on it, you're actually pressing on several of these bars. So by using cubic interpolation, you can very accurately
Find the center.
okay. Well, anyway, another excerpt from the Nerd Show. But that's when cable TV, local cable channels came out at that time. So that was fun. But in any case, yeah, so that actually looks sort of like this does, at least superficially. I built a full-size prototype. Is Mark Smart here now?
He had a flat tire.
Oh, okay. Well, here's his. So he helped build this one. If this one looks like I got angle iron at Farm and Fleet and some black cloth from, I can't remember what, I think from a bed sheet or something. I can't remember. But anyway, so it was rather low tech. I did have a high tech 2-monitor system on my Mac though. So that was kind of cool. But anyway, so he helped build this prototype. The prototype actually worked quite well. You didn't want to. You definitely wanted to electronically much amplify the sound because it rattled a lot, like a good prototype should. But it actually worked quite well. The pitch accuracy still wasn't there. I could roll my finger. So when you roll your finger and do this, your finger's a big fat thing. But actually, it's to 10 microns you need. You know, or in mills for you non-metric people. See, we have thousands of inches because that's not metric. But anyway, and kilofeet. But in any case, we have in mills it's about a half a mil to a third of a mil. You need that sort of center of gravity accuracy. Now your finger's real fat, and you certainly can't just put your finger down to that accuracy. In fact, there's flab in your finger, there's bones in there, so all of it is part of an audio feedback loop. But when you move your finger very slightly, which is I really, you know, that was paramount. I came from violin and viola. This still couldn't do it, and that's why I didn't sell that. Okay. Here, this sensor is the most depressed one here, but if you draw a parabola through it or some other fitting function, actually other things work better. But you can see that you're actually slightly to the right or slightly to the left. So I got orders of magnitude more accuracy than the spacing of these bars, just by some simple tricks. In fact, the accuracy is so good now that I have to worry about magnetic field interactions and all sorts of stuff. But got the light action working, and it has to do all that. Okay, so let's see what I'm supposed to do here. I'm supposed to show some things here. First of all, I wanted to show what a modern continuum looks like on the inside, sort of. Here is, how late are we here? 9:26. I better not go too long. I was going to take this frame apart. You'll just have to take my word for it. But this is a modern full size. It has a tray, as I call it, on the bottom. I don't know where that, why I have that name, but it's been called that. And then these are sensor boards. They're all along the length of it. There's some ribs in the bottom just to, well, there's one under here, just to keep it very, very steady. Inside here, you can't see this. Or, I could take it apart, but just believe me. There's an angle piece here so that when you take off the top, by the way, don't take off the top if you got an old one, because these angle pieces were laid out. When you take off the top on an old one, you got a big mess of springs everywhere. And you can try to put it back together. I can do it in about 8 hours, so if you just send the mess to me, I'll fix it. And actually the worst is if you don't trust your own workmanship or your ability to fix something, and you go to a keyboard, a store, that's a person that's fixed keyboards all their life, they're the worst because they don't read any manuals, they already know. Yes?
How old is an old one?
Oh, 2009 probably? I don't know. I'd have to look. Yeah, basically.
So the classic touch ones, are they all the older ones?
I don't think so, actually. I can't remember.
I'm actually not sure if you have a light action, you could have one with a spring schema.
I don't think so.
I have the angle iron.
Anyway, I give you instructions. So write me email, and I'll tell you how to avoid disaster. And when you take off the top, you can say, "Oh well, that was an extra step. It'll take you like a minute to avoid disaster. You just have to put some weights on top." Anyway,
Lippold can trace it via serial number too.
Usually, yeah. My records are usually pretty good. Hey, Apple can't keep track. They're telling me my phone says something different on that. So not everybody's perfect. But anyway, so then at the ends of these, there's these springs on these pins. And the springs go into very carefully crafted holes in these rods. It took me wasn't until after 2000 that I figured out how carefully crafted those holes had to be to make the smooth action. There are multi-step holes. I brought a microscope in. If you're interested later, you can look down those holes. They're a complicated thing. But in any case, that's where the rods are going up and down the spring. And then there's the neoprene and some other rubber and such on it. But that's basically what it looks like. Is this thing, the bottom half of it is air and a power supply, and not much. And on one end, the DSP. If you got the 3 times upgrade, I use a little bit more of the air. But again, I could make it half as thick. It's expensive as a boutique manufacturer. These are already expensive, and if it has to come from somewhere, I have to pick my battles. So yes, if these were actually mass produced, you'd make them half as thick, and this edge wouldn't have to be as large and stuff. A lot of this stuff is, if it works and it doesn't actually improve
just going to pass
playing,
these around.
Oh, sure. Is that a new one or old one?
I don't know. Which these are old?
Yeah, those are all old.
Yeah.
Let me look at them. Do you want a new one or an old one?
Doesn't matter.
Okay, I'll just look at them. I'll tell you what's different. Okay, so these are old ones. Oh, here's a square one. Those are really old. There's even older square ones with the magnets on the bottom. Then there's all of these have magnets sticking out the ends. They don't do that. I mean, these are made of aluminum now. All these rods are. I think. Yeah, even this square one. I've made steel ones in the beginning too. But the magnets are actually crimped inside rather than glued. These are glued, and after a few years, sometimes the glue cracks. And I tried different kinds of glue and stuff anyway. So now the newer ones, because I have better precision machining, the place that machines these actually also makes Swiss watch parts. So this isn't by the most accurate thing they make, but they do it so accurately that what we actually do is put in the rod and then crimp it. And I don't know, there's no examples of that here, but you can pass around. They don't look like much, but they really matter. It's like a princess and pea problem. You do the wrong thing with those, and then you can feel it. Yes?
Are there any possibilities that you could mess something up if you had strong magnets near the instrument?
Not permanently. You could definitely mess up your calibration. And even the other way, these magnets aren't that strong because it turns out there's this trade-off eventually. These are Alnico 8 magnets, which are, actually when I started they counted as very good magnets. But if you have too strong a magnet, then you have too much interaction between the magnetic fields. As it is now, I can mathematically work out the issues with neighboring magnets and how they affect neighboring sensors. But it's non-trivial as it is. If the magnets were too strong, it doesn't help much. The Hall effect sensors are similar. They come in different dynamic ranges, but they have about 14 bits of accuracy no matter which range you pick.
Did you experiment with different magnet sizes then to figure out that sort of optimum trade-off?
Oh yeah, magnet strengths, magnet sizes, magnet positions, all sorts of. Because also the magnetic field is sort of a funny thing, and you really want the Hall effect sensors to be in a place where the magnetic field. So one of the reasons they went with round rods is to get the circular symmetric. First I had flat rods and the magnets on the bottom. So if the rod rocks at all, the magnetic field is very different. So I figured out, put them on the ends and make it vertical. Then circular symmetric. And then I figured out, no, don't do square at all. Do round for other reasons because of just if you put the right material on top, you get a smoother feel. Yes.
Is that the type of thing where hysteresis might play into it too? You might get a little different curve on the downstroke than you do on the up?
Yeah, so there's all sorts of things there. Most of the hysteresis actually comes from the neoprene. Mm-hmm. And usually it's what you want. So it's a complicated thing, but especially with the light action, actually Ed noticed, I don't know if I'm supposed to publicly say this, but noticed a bug, at least in the version he's using. So sometimes
that everyone's using.
Yeah. I don't know, because you're using 755. I don't know if 754 does the same thing.
Okay, well.
I don't know when I put in the bugs. Certainly, anyway. So there's a lot of processing there, and occasionally I screw things up. So if you do notice weird things, so let me know, and then I can tell you pretty easily, hey, for this particular thing, that's the way it is, or like originally I had wanted to do a whole field of sensors, but with Hall effect, if I want to buy good Hall effect sensors, it costs enough a piece that it's just, this thing is already expensive, so to do a whole field of them would be crazy expensive. There's also actually other reasons, detailed reasons why I wouldn't get the pitch accuracy, and if pitch accuracy is paramount, then this is actually a really good setup. All right. So what else do I have here? I worked on lots of stuff. I mean, those are the rods. What goes with the rods then is also trying to make it so that then these circuit boards, the parts I use, there's all sorts of things that they do in circuit boards very accurately, but to make pins that are up vertical, perfectly straight, like to better than to a tiny fraction of a mil, they just don't do that. So what they do when they solder these things is I made them machine the solder plate, so everything is put together after all the chips are on and after everything else is on it. It's all put together with special jigs so that things are really straight and really perfect. And then in this thing, while this thing is all heavy and things are pressing, it's very carefully decided where it presses what, because actually the mechanical part of it has to be really right for things to work well. I had lots and lots of things I did with surface material. Very early on, I used Mylar, which I don't have an example of that. Then I tried Mylar with different kinds of rubber on it and rubber by itself. And actually, at one time, here, you got to pass this around. At one time, that felt like a good surface material. Anyway.
If you're a deep sea diver.
If you like that one, you're, I'm sorry, I'm not going to go there. So then I eventually got this thing that the person, there's still one person has a Continuum. I don't, are you here? That's still using this material. They're calling it the cat house material. We have that. I don't know what that means.
The first time I played a Continuum, that was on it.
Yeah, so this was a local seamstress. It's got vinyl on the back, and it's got, I don't know, something very nice here. Pass around. It feels really good on. Any case, this is a total fail because what happens here, it has to be supported on the edges, so it's stretched like a canvas would be stretched. So when you're playing near the edges or you're playing anywhere, you're pushing against the material. And so, anyway, stupid. But didn't know any better. Eventually, we went to neoprene. I had endless things. I got plain neoprene. I wanted to glue different things to them. I have literally thousands of tests of different kinds of spray glues, some of which were more disastrous than others. I could never get a big surface. Or again, it's a Princess and Pea problem. There's going to be somewhere where you can feel some of the bumps underneath. So it went on and on. Oh, I had some cool ones. This is a cool one. I wanted to, try with different touch feedback. On one side here, this is a drawn surface where we got neoprene. And then I also was experimenting with different kind of touch feedback. This is fishing line I tried to glue on there. There you go. Lots and lots of stuff. Eventually, the first sort of real thing that worked, I finally found a Sharpie that would let me draw on there. And I made a template so that if you draw the lines on there, see if I can.
Wow. You want to get that out?
Yeah, give me a hand here.
No.
Yeah, I made this template, which is actually quite precise. Would draw lines on the material with this template with the proper kind of Sharpie, and for about, it depends how many hours you play, but if you play many hours a day or if you have sweaty acidic hands, it didn't last real long, but it sort of worked. So this was the Sharpie thing. There are black lines and silver lines. It was too hard, like if you have a jump of a couple of octaves, it was too hard to see where you're supposed to go. The D's had little extra dots on them, yeah, so I did that for a while. So then I went on to, we got silk screening. The problem with the silk screening normally is that if you get ink that really lasts, the curing process, well, anyway, if you heat cure things, it doesn't work too good. This was silk screening, which was pretty accurate, but not quite good enough most of the time. So this was professionally silk screened, white and black keys, lines in the middle, because I thought, well, you want the reference in the middle. Again, this pattern, even if you're used to, I'm not even a piano player, and I couldn't see the pattern fast enough. So it seems nice, but you really need the big black area. It's just this reference. We did make these cool coasters. So if you really want one of these, so this is the same pattern as this, and this is neoprene. You can see it's too thin, but it is neoprene. It's also the wrong kind of foam. But anyway, so there's these. No, they're not coasters. They're what do you call it?
Drink holders.
Drink holders. So if you're on your boat, you put your pop can in there, and it'll suck it to the surface, and with your pinky you can pick it up and drink something, and then suck it back down again. So these are really cool, and they had the same infinite pattern that the Continuum did. In fact, the Continuum still has D in the middle, so that you can play it from either side as long as you reverse pitches. Sometimes useful at a trade show. You can play for them, then hit reverse pitches, and then they can play. But anyway, that's that. I wanted black and white areas, but this silk screening method couldn't do wide stripes. By this time, we had, anybody got this, a laser etched surface? You still have it?
I still use it.
You're whacked. Okay. Well, anyway, this laser etched surface, I tried a lot of things. I have lots of examples here that I don't need to show. Like these things look good. This says Utah UU clear. There's some place in Utah that printed this for me, but anyway, they refused to do it because it stank too bad when they did it because the neoprene was heating up. I had lots of them, but so this thing here, laser etching worked great. Laser etching was perfect, and these are 20-cent lines. So you really have, very nice, very easy to line up, very accurate, very wonderful, very everything, except it doesn't wear well because, right, when you're laser etching, it's black because you're seeing the neoprene through it, so your fingers catch on it eventually and rip it up, so it just doesn't last very long. What's that?
Why did you choose red?
Well, because white, okay, early on I had the cat house material, and it stayed red. That's sort of the short answer. I did try white, and I tried different colors on white. Like here's black and white. We have many different things. White looks gross after a while. Red doesn't look as gross. With red, you can. Yeah. With red, you can clean it with Windex or something, and with white, it's just hopeless. It doesn't. Also, the white, in this particular one, this white doesn't feel so good because this is actually double nylon because we wanted the white really white as opposed to just gray. And so it's also stiffer. You can't tell when you're just holding it here, but if you were to play this, or if Ed were to play this, he would complain about it after some
I
amount of
just
time.
complain about everything.
Yeah, here you go. Okay.
What happens if you
So I had gotten white initially because I wanted to put all different colors on, just have you custom make them. The printing process, again, there is no digital printing thing where the curing. So if you want to be able to rub on it for 10 years with your fingers, there's no thing that does it. Okay, I got to hurry up here. I see people. What do we have here now?
Don't worry, Lippold. You can go to mine a bit.
Well, no, I'll never shut up. So we have some more here. So do we have an A.R. Rahman fan here who would like, or here's a Jordan Rudess one. This is on the 2009 tour. If you want his sweat, it's yours. And there is, this is Rahman on the India Unity video. Anyway, so there's the India Unity video is nice because it was shown in lots of schools there. They tell me it was shown to 100, some insane number, like 100 million school kids. So some insane number. It's a, yes.
You need to hold it again. I'll make a picture and upload it. So it makes
Oh yeah, you can sell it.
Yeah.
Just don't tell AR that I did because I don't want to be involved with that. So there you
He
go.
won't mind.
Thanks. He won't.
I don't know. Who knows? I just can't afford to do it. So anyway, this is another historic surface of some sort. Okay, so a modern one now, finally. Oh, there are ones here, like that AR one with silk screen. This is done by a company that does building wraps. So my big problem was it needs really low heat curing to really last for 10 years or so. It really needs low heat curing. And this building wrap company normally does things that wrap around skyscrapers. So they have, like a quarter mile by quarter mile rolling oven. Anyway, in one corner of it, they stick my puny little 2x3 meter sheets, and it rolls through with the right temperature curve and stuff. And the guy there really wanted to get into NAMM, so he developed ink for me and did this, and sure enough, it worked great. So I did these for a long time, and some of you hosers still want this. It's sort of a hassle. What's that?
I have the same.
Yeah, but you don't. You would actually like the new one better.
Yeah.
So, see. So listen to him. So what happened with the new one is this is pre-printed nylon, and so this is custom made in China for me. Actually, neoprene was the whole process was invented in the U.S., but it's so stinky it's only done in China now. But in any case, this was done in China. They made the nylon with the pattern on it, very very clear to see. And what else can I tell you about it? Yes, so it's pre-printed, and the way neoprene is made, it's made in this huge pie pan, shallow pie pan. It's 2x3 meters. It's a liquid stuff. It rises like a cake, and then it falls. And before it falls, this stuff is applied in some method. I've never been there.
The unfortunate thing of dealing with China is that our back and forth between each step was months and months.
Yeah, and then you have the helpful salesman that tells you a quick answer that sounds convincing, but doesn't actually know what they're talking about and all that. So anyway, so it was. But now we have this material because of the way the neoprene shrinks as it's made. It can shrink by a couple of millimeters per octave, which doesn't sound like much. But anyway, so this is highly stretched on the newer continuums, and it turns out there's a side benefit of that is the response is actually faster because, as I was saying, a lot of nonlinearity comes from the neoprene. That the response is faster because a lot of the nonlinearities, which are useful, right? If you just have springs, it's linear, and when you press harder into it, it doesn't feel right. You really want something like a sponge that compresses more and gives you more resistance. So I have a combination of springs, which are totally linear. F equals kx is like planetary motion. Not very many things that are really follow physics. But the springs are really linear, and for sensing that's great. But over them then, the nylon is, the neoprene gives a much better feel. Actually, the two together give a better feel than if you just put the thing on the table. It doesn't feel that good either. Rubber alone has a lot of problems too. You really need the springs for accuracy. You need the rubber for feel. Also, the rubber, in this case, it was very important to me, like a violinist can play with his pinky, and a lot of sensing systems that I tried and that are on the market now, if you put a pinky down, you can't do the same things with a big finger, fat finger or a bony finger or a flabby finger. Here, because of the way the neoprene is so uniform, you can, same pressure, doesn't matter what kind of finger you use, or if you're crazy, you do what Peter Pringle recently did and used tiny little pins. Hey, you can use all sorts of stuff. Yeah. What's that?
Or your fist.
Yeah. So anyway, or you can use your fist, or I have some inappropriate straw. I better not say that because my wife will watch this. But anyway, all sorts of things that people wanted to do now. So the only other thing is a new one also. It has these rails on the inside so that everything doesn't fall apart. It also has this nice feature that when you have a new surface, you just snap it on one side and snap it on the other side and put it on. That may not be yours, so I'll always ask for instructions. My real goal is that you don't have to replace the neoprene all the time. You have to tune it, or in this case, you have to calibrate once in a while when you move it and that sort of thing. But the intention is that not that you're replacing surfaces all the time. Okay, well, I'm about a third of the way through my talk. I better cut this out short here. Okay.
Better have more to say.
Well, as I warned you, I teach at a university, and everybody gets a grade, and they're trying to stay awake and take notes and stuff, and if they don't, they're in trouble. So, so I have a wrong background for doing a quick talk. Okay, in 1999, so I worked on lots of this stuff. In 1999, I sold my first one to Edmund Egan. I had built some other, I was building them all the time. Most of it was throwaways. Of the first 16 I built, 7 actually ever saw the light of day. There's just too many production problems because I didn't have those solder plates yet. I didn't have all these other things. So there's a lot of waste. The marginal cost of building one is much lower than the overall cost. But in 1999, I had made a deal with my wife that I would not put up any money. This is all going to be self-supporting, and I have a day job to pay the bills for the family, and the Continuum stuff. So that money goes back into itself, but we won't lose our house or anything else due to stupid mistakes or supply problems or something. So in 1999, Ed bought his first one. There's some very original. If you're ever in the mood, look at the 3 Streams video. I don't know. That's Kima and. I think your first Continuum.
Yeah, or Arabesque, that one that I did, the vocal Kima, analysis.
So
I played on that.
He makes it look like it was playable, and it was pretty good. So there's some nice old videos there. I sold my first half size, which was serial number 1. I didn't really put one on his, in 2001.
You were worried about Y2K.
That's right. That's right.
I think we have a former owner of that one in the audience.
So yes. So
serial number 1 had no printing on it at all. It was solid red.
Yeah, well, it was the cat house material, right? Yeah. Okay, there you go.
With the triangular.
Like I say, we have kittens.
It was really difficult to play.
He's familiar with that too. Anyway, you learn. As an engineer, what I did is I did these tests to see, well, how accurate can you do pitch? But in an ideal situation, it was actually good at measuring pitch. It's just, well, actually playing it was another step.
It was good at whale sounds.
Yeah, yeah. So in about 2004, I started using the L foam from a very good manufacturer. It's great. I added rounding because Jordan Rudess asked for it, and Jordan Rudess was great. He was the first really well-known person to buy this. He bought it off a article that I forget who wrote, but anyway, an article in Keyboard Magazine. And, you know, of course, he expected to get it for free. And I told him, look, I'm just a guy out of the basement. I can't do that. And he was very gracious about it. You know, I told him I'm just a poor slob and stuff. He did it anyway. So I was eternally thankful for that. So he went on tour with it. And after it survived that tour, it was like all the penguins, you know how they stand on the cliff and they wait, you know, when the first one falls in, they look, is it going to get eaten or not? And didn't get eaten, now they all jump in. Well, so all these people that contacted me, and they basically, even independent of what it could do or not do, they knew it could hold up to a Jordan Rudess tour and work all the way through it. And as long as it did that, they said, oh yeah, we'll try it. Because, you know, most new things are kind of hard. So, yeah, I have misgivings about rounding. I still do. I'll talk about that a little later. If you want to do rounding, check out the new Y-based rounding. That has fewer of the problems. I designed a CV specifically for the Continuum. Here's a short example for those of you who have not heard the Continuum controlling analog, because the Egan matrix has been so successful now that many people don't even do this anymore. But here's a short example that Ed recorded a long time ago. And you know, for those of you wanting to save money, this is classic action. This is old. You know, this is, you don't have to have the very latest for everything. Except this Piano Tech piano, or somebody.
Yeah, it's a Modar piano.
Modar, before Piano Tech.
No, it's the same thing.
Okay. So this is controlling Moog Voyager. Should I stop it or play the whole examples? It's short.
Yeah, you're halfway through here.
No, it's all Voyager. It's just in the fingers. The only thing that's not Continuum is the piano synthesis.
Yeah, there's like 3 or 4 tracks.
Yeah, he did 3 or 4 tracks.
I challenge anyone to play that.
Yeah, exactly. Exactly. And you,
Well, I mean, like those where you hear just like thirds going on the strings, is that 2 separate one line?
I think-
or is that actually like?
Every track, yeah, well, Voyager's monophonic.
Yeah, he did. Yeah, he did everything monophonic,
Yeah.
and okay. So here's another example with the Voyager, just to show that it isn't same sort of setup actually. Okay, so I'm going to stop this one because obviously you want to hear me talk rather than actually hear music. The reason I played these, the reason I played these was just so that this next example, because I realized, oh no, this example I'm showing is this nerdy test. Here's a nerdy test. Listen to this here. This is the Voyager, which has MIDI in. Voyager controlled by MIDI, just Ed noodling around. So this is over MIDI.
but on a regular MIDI keyboard.
No, this is on the Continuum,
Oh.
but so that's just noodling around. But now listen to this. This is the same sort of noodling around. It's not exactly the same thing. You just play it again. But this is through our voltage converter. So basically, there we're using the built-in voltage converter. Here we're using our voltage converter. This is why I designed the CVC, basically. That kind of staccato stuff is just not available in the other, no matter how we try to play.
No, that's not the reason.
Yeah. So that's a big thing about MIDI. The confusion about MIDI is deadly. The most common one is MIDI is slow, which is true, and it's never the problem. The problem is that modern DAWs can't accept MIDI at the full MIDI rate. A normal keyboard sends about 5% of the MIDI rate, and a DAW is all optimized to do sample processing and other things. They also tend to reorder MIDI messages and all sorts of crazy crap. But the thing is, why would the Voyager smooth the MIDI that much when clearly it can do this? Well, the reason is, historically, this is me talking, and you're my students, so you have to regurgitate what I say. If you know otherwise, just pretend for now. But no, so early on, when MIDI came up, suddenly manufacturers could just make keyboards or just make synths. If you're making a synth and you're in a store with it connected by MIDI to the crappy keyboard that has a 3-cent pitch wheel, which has huge jumps in it and sends crappy data, well, your synth sounds bad. People won't buy it. So you go and you smooth the hell out of pitch bends, and guess what? Then it sounds passable. Same thing is going on now with alternative controllers. We could talk about that later, but you have very slow data rate, very little information, and yeah, it still sounds reasonable. In fact, it's sort of a clever use of a cheesy pitch bend. But the problem in MIDI is you can't tell it, hey, I'm sending it this data rate or that. Yeah, more about that later. But
if I may, Lippold,
yes.
There's another thing. The design philosophy of the Voyager, I don't want to discount like the Voyager was done wrong, but that's controller 7, so that's the master volume. So most people would just be using it as a volume control with low data rate, not trying to create a BCA out of it.
But again, it's the same thing. It's history, right? There's nothing inherent about MIDI. The MIDI data rate is plenty. In fact, the second example was done. It's converted to MIDI before and then internally driven out to the... It's converted to MIDI internally, then from MIDI back to stuff for the CVC. But I'm interpreting the MIDI. The other thing is that you buy a really nice CV and it's got like automatic vibrato and other features that you don't want anyway. So it's very hard to find. All outputs are 16 bits. All so on and so forth. The whole thing. So we built our own. I started selling Continuums with Sharks. It took a long time to get used to them. Shark is a super hardware architecture, which means if you're into computers at all, they have many, many buses. All the standard computers like ARMs are like 99 or 95% of the computers in the world are ARM processor design, which is a von Neumann. There's a single bus. Data memory is the same as program memory and all that kind of stuff. And the hardware architecture, you have many different data buses, many different program buses, and many different memories. Very, very effective if you custom program it. In fact, if any of you are Shark programmers, I know I get asked every time I go anywhere, hey, do you know anybody that can do this? After I refuse. Lots of people looking for those skills. So then out of that Shark, the reason I did the Shark is we had a general purpose computer that couldn't scan the fingerboard fast enough. So out of that came so a general purpose computer could only scan every 4 milliseconds because the magnetic equations and stuff got too complicated. When I went to the Shark, it was using less than 4% of the processing power. So it's like, okay, I went from over 100% to less than 4% for 3 milliseconds. There's lots of reasons for that, but in any case, I had huge amounts left over, and that's when we started working on internal sounds and the Egan matrix. The initial internal sounds was a simple FM thing, it's still there. Those first FM sounds, they're just because it's so hard for people to tell that it works or not. Did Mark come in yet? Still flat tiring? See somebody else who's bald. Oh, yeah, you're not Mark, are you? Okay. Mark knows I don't know. I mean, I sometimes forget his name when I'm trying to introduce him, which is really good. Okay, so the Shark is a big deal, but for a different talk. In 2012, I believe, or it's sort of spread out, because you always have to have some people who try it and work out all the bugs. But around 2012, I started selling the Light Action, which is a story into itself, which I won't go into here. Should we take a break and then I'll do this thing?
We're at the end of your.
I know, but he's going to give me some of his. He said so.
Okay.
Yeah.
Oh, wait!
You know, it's
Come
good
up here and
because
play
mine-
this thing. Play this thing for people. If you want to come up, during the break, I cut up the neoprene on this one so you can see the rods moving underneath. The thing you'll see is the bars actually do not move very far, and this isn't quite as accurate as the real thing because it's all sliced up. But you can still. Yeah.
I found this cool way to do pitch bend on this one, so you can.
You cheater. Anyway, I have a camera here I could do this with, but you know what? What's way cooler is if you just want to play with it, you can sort of watch what the bars do, and there's very interesting, weird patterns with them because
Or try
they
playing the bars.
or you can try playing the bars. Don't be real mean to the bars because they are sensitive things. You can be much more mean to the neoprene than to the bars. But there's very small motions that are complicated sometimes because the magnets repel each other. But in any case, you're welcome to do that. That'll get rid of a demo I would do afterwards. Another thing is this Lego robot. If I had it plugged in, it would sound exactly like you expect. When I was doing the live action, I needed something that could play for 16 hours. I had a computer. I have secret outputs from the Continuum that let me log special events. I know exactly what the interval is. I know exactly what it's supposed to be doing. So then I would, my longest test was at the end when I really got the light action going was a 1.5 month long continuous test to make sure there were no spurious problems. Because a lot of the problem with light action wasn't just the sensors and stuff, but it was also the serial communications with the sensors, with A to D converters. In any case, this thing has been very useful. I even used it this trip to fix your Continuum. Because you had that weird old problem. So the weirdest problems I really need this for, and it works great. It is just a Lego robot. My kid made it for me. And the top thing is a top frame. Those holes on the side were drilled 1 millimeter off, so I couldn't use it for anything. So it guides the robot back and forth. And those things at the end are just what they look like, old scuba weights. It's whatever is lying around in the house. Okay, thanks. We're going to do a short break, right? Or how do you want to do this? I think people need to get up and stuff.
Yeah, me too.
You know, all the things people are going to be talking about, they don't understand any of that stuff, so. Yeah.